I was listening to songs. But students, have you ever thought, how is the sound coming out from this headphone and we are able to hear the songs through mobile, through headphone, through speakers, in TV? Well, I'm not going to give you the answer now until we meet again. We have met again, and this time with a magic. And students, you must have seen magicians performing tricks with balloons, a constant balloon moving in the air. Well, let me tell you, the world is not about magic. It is because there were two magnets, one in my hand and one inside this balloon, which were attracting and repelling. So students, let me now take you to the world of magnets. So students, I told you that we are ready to go and have fun with magnets. So now I have brought you here. So let us learn why we have fun with magnets in this chapter 13. But before that, let me show you what will you earn and learn at the end of this lesson. At the end of this lesson, you will be able to determine which objects are magnetic and which are not. Observe that magnets have two sides, north and south. Predict the motion of magnets based on knowledge that they repel and attract. Apply the process of identifying main idea and supporting details to show how the force of magnetism works and how it can be useful in everyday life. And finally, classify the objects as magnetic or not. The history of magnets is a very long one. It goes to long 1,000 years ago when there was a man, an old shepherd called Magnus, who lived in Magnesia, which is a village in northern Greece. One day, he went with his sheep for grazing, and while he was grazing, he had a stick with an iron at the end of the stick. His stick suddenly got stuck to a stone. Initially, he thought it was magic, a magical stone. But later on, we realized that the stone had attractive properties. He named the stone as magnetite, and this is the color of the black rock called magnetite, which Magnus discovered. This black rock called magnetite has given the name magnet, and today we know in this modern world that magnets have all come from the natural rock called magnetite. Students, I have already told you how Magnus went to graze his sheep in a place called Magnesia in northern Greece. He had a stick with him, of which the lower part was made of iron. Let me show you how he discovered that magical stone called magnetite. When he was grazing his sheep, the lower part of his stick, which had iron, got stuck, and he could not remove it so easily. He gave a theory that it was some sort of magical stone. But later on, we found that the stone had some attractive property. And this is how the stone called natural magnetite was discovered. What magnets do? Magnets attract certain materials like iron, steel, cobalt, nickel. Apart from iron, steel, cobalt and nickel, magnets do not attract any other materials like plastic, glass or rubber. What properties do they exhibit? Magnets have two poles. As you can see in the figure, and with a magnet in my hand, a magnet has two poles, one north pole and another south pole. Like poles or similar poles always repel, whereas unlike poles or dissimilar poles always attract. Let us see it. For conducting this activity of attraction and repulsion, I have two sets of different magnets, as you can see on the table. This is called repulsion because the like poles of two magnets repel. And this is called attraction. When unlike poles, North Pole and South Pole, they attract. Similarly, in the case of these two magnets, this is called repulsion because the similar poles repel, and this is called attraction. This is exactly what you had seen in the activity. North pole of one magnet and north pole of another magnet, which are the like poles, repulsion. North pole of one magnet and the south pole of another magnet, which are the unlike poles, attraction, similar to what happened in the activity before. The other very important point, the property of a magnet is, when suspended freely, a magnet always points towards north-south direction. As you can see in the figure, a bar magnet which is suspended shows north-south direction. Now, to see this, let us go outside and see. Students, in this activity, I have a bar magnet which I have suspended with the help of a thread to the branch of a tree. Now, as you can see, the position of the magnet is in this direction, which means the dot out here is the north pole of a magnet, and this pole of a magnet without dot is the south pole. It means a freely suspended magnet always points towards the north-south direction. This is because the earth itself is a very big magnet, and the geographical north pole of the earth is actually the south pole of the earth, which is magnetic. That is why we see that a magnet is always facing in the north-south direction. Magnetic field. The force of attraction around a magnet is called its magnetic field. As you can see in this figure, a bar magnet has been placed, and around it there are some lines, circular lines. These lines are called magnetic field. We can actually see magnetic field of a magnet. Let us conduct an activity to show the magnetic fields of a magnet. For conducting this activity, we require a bar magnet and some iron filings which are placed inside this cup. We place this bar magnet under the paper and spread some iron filings over the paper. As you can see, students, very beautiful magnetic field lines can be seen around this bar magnet, what you had seen in the picture. So these lines of a magnet around it are known as magnetic field lines. Students, have you ever wondered where will the force of attraction be more in a magnet? Will it be towards the center? Will it be towards both the poles? Or will it be only towards one pole? Let us perform an activity to show the area of maximum attraction of a magnet and find it out. For conducting this activity to show the area of maximum attraction in a magnet, we require some pins and a bar magnet. When we bring these pins near the bar magnet, we find that more number of pins are attracted at the poles of a magnet. Therefore, we can prove that the maximum force of a magnet lies towards the poles. Therefore, students, the answer to this previous question, that where will the force of attraction be more in a magnet, is the second one, that is both the poles. This is because the magnetic field lines always originate from the poles of a magnet. Do magnets attract all materials or every type of material that is mentioned here? Well, Let us find out by performing a simple activity. Well, to perform this activity, we need a piece of magnet and some items placed on the table. Let us start with a spoon attracted by a magnet. Let us keep it here. Let us start with a ruler, not attracted. Then comes the wooden duster. Then stainless steel knife, an eraser, a blade, a glass cup, a bunch of keys, and a plastic doll. Therefore, these materials are non-magnetic, whereas these materials are magnetic materials. So from the activity that we have done, we can sort materials as magnetic materials and non-magnetic materials. Materials which are attracted towards a magnet are called magnetic materials, whereas those materials which are not attracted towards a magnet are called non-magnetic materials. Students, artificial magnets can be made into different shapes and sizes. We come across some shapes of magnets even in our junior science laboratory. Some of the common shapes of magnets that we see every day are horseshoe magnet. You can see I have a horseshoe magnet with me, and in the figure also you can see a horseshoe magnet. A bar magnet, cylindrical magnet. It is very small in size, although with me, and in the end these are known as ball-ended magnets. Of course, there may be other shapes of magnets. For example, I have a ring magnet with me, which you can see. Therefore, these are the various shapes of magnets that we commonly find even in our labs. Number 1, horseshoe magnet. Number 2, bar magnet. Number 3, cylindrical magnet. And number 4, ball-ended magnets. Now that students, you have seen the shapes of magnets, we have done some experiments with magnets about their properties, the property of attraction, the property of repulsion, the property of showing direction. Now let us see what are the various applications of magnets, where they are actually used. The first one, used in doors of refrigerators and steel almirahs. Students, sometimes we may forget something and write reminder notes. For that, a magnet is the best thing that we can use. As you can see, there is a magnet at the end of this. And I can write some notes and keep it in an almirah, steel almirah, or a refrigerator. Magnets are also used inside TVs, sound speakers, radios and mobile phones. Students, in the beginning, I told you that I will give you an answer later on, and I was listening to music on this headphone with my mobile. And now you must be knowing, where is the magnet used? Of course, it is used in the speakers inside the mobile phone and the headphone. Also, they are also used inside the speakers. of TVs, of radios, of computers, etc. They are used for making magnetic compass. A magnetic compass is used to show directions. So here we can find the direction by using a magnetic compass. There is a small compass needle attached to it which shows north-south direction. Magnets are also used in ATM cards. You must have seen people using ATM cards. Your parents. There is a black strip here. This black strip is made of magnet. Here many information is stored and we can use these ATM cards for withdrawing money and many other things. Separating metals from garbage. You see, in a garbage there may be many types of materials, magnetic as well as non-magnetic materials. So, when we bring a magnet near the garbage, all the magnetic materials like steel, tin cans and iron items are separated from the garbage. Magnets are also used in our small items like geometry box used by students. You see, this geometry box can close and open. It is because here there is a small piece of magnet attached to it, and because of this it can open or close. And you must have also seen the wallets and purse. Here too a small magnet is attached, because of which this can close easily. Therefore students, from a small thing to a heavy item like a 100-ton garbage collector, magnets are also used, artificial magnets. These are some of the common items where magnets are used. As I have already told you, ATM card, sound boxes, a magnetic compass, the speakers of mobile phones, a heavy crane lifting magnetic materials from garbage, and the doors of refrigerators, which is used to open and close with the help of magnets. We have learned about permanent magnets or natural magnets, but can we make a temporary magnet? And the answer is yes. All we require is a bar magnet and an iron nail, and a very simple process known as single touch method. Let us see. As I told you, for making a temporary magnet, we need a bar magnet and an iron nail. What we do is, we rub the iron nail from one side of the magnet for about 20 to 30 times. In this way, we are trying to magnetize this iron nail by single touch method. So this is actually what is known as single touch method. Now, to check whether this iron nail has got magnetized or not, we bring it near a pin and we see that this pin is easily attracted by this iron nail. Thus, we see that it is possible to make a temporary magnet. There are other types of magnets like electromagnets which are made by passing strong electric current through iron. Now these type of magnets are used for separating garbage and in superfast trains. Can a magnet lose its magnetic property? Well, yes, a magnet can lose its magnetic property if any of these is done to the magnet. By heating, if we heat a magnet to a very high temperature, the magnet will lose its magnetic property. By hammering a magnet, a magnet will lose its magnetic property. By dropping the magnet several times, a magnet will also lose its magnetic property of attraction and repulsion. And of course, the most important, improper storing. When we store magnets in an improper way, the magnets will lose the property of magnetism. Well, students, let us now see the correct way of storing magnets. Students, as I told you that storing of magnets in a proper way is very important. So, how can we store magnets? I will show it to you. For storing of magnets, we require a small piece of wood, magnetic keepers. If I have to store bar magnets, a piece of wood is placed between these bar magnets attached by the keeper, and then we place it in a box in this way. This is the proper method of storing a bar magnet with another magnet. However, for storing a magnet which is known as horseshoe magnet, we use a single magnetic keeper and then we put it inside a box. This is the proper method of storing. Whereas, if we store magnets in this way or without a magnetic keeper, the magnetic property of magnets is destroyed. What happens when we break a magnet into two pieces or several pieces? There are three options. A. Poles are separated. B. Each piece will have like poles. Each piece will have unlike poles. Let us conduct a simple activity and find out the correct answer among these three options. To conduct this activity, we require a magnet. I have taken a ring magnet and I have already broken another ring magnet and made into several pieces. We can see that there are four pieces of this magnet, and when I bring two pairs of magnets, there is attraction. And when I bring another two pairs of magnets, there is repulsion. It means that all these magnets have developed one north pole and one south pole. That is why when I bring two opposite poles, there is attraction, and two similar poles, there is repulsion. Therefore, we get the correct answer. Thus, we see that even if we break a magnet into several pieces, each piece of magnet will have two opposite poles. That is, one north pole and one south pole. We had conducted that activity and we have seen that when the magnets were broken into some pieces, there was attraction and repulsion between two different pairs of pieces. Same is the case here. When this bar magnet is broken into four pieces, these four pieces have developed opposite poles. South pole, north pole, south pole, north pole. Therefore, students, the correct answer to the question which I had asked you is number C. Each piece will have unlike poles. This is the correct answer. Students, in this chapter called Fun with Magnets, we have learned a lot about magnets, about how magnets were discovered, what are the properties of magnets, and where magnets are used, the applications of magnets. And we have conducted some activities and experiments with magnets. So let us take a small quiz to test your knowledge in this chapter called Fun with Magnets. Let us go for the first question. A dash is an example of natural magnet. Bar magnet, ring magnet, magnetite. And if you have guessed the answer as magnetite, you are absolutely correct because magnetite is a natural magnet. Let us go to the second question. A magnet is strongest at its center pole's back. We had conducted an activity taking a bar magnet and some pins, and we saw that more number of pins got attracted towards the two poles of the magnet. That means the answer to this question is poles of a magnet. Let us come to the third question. Opposite poles do which of the following? Repel, attract, break. If you bring one north pole of a magnet to another south pole of a magnet, they will always attract because opposite poles of a magnet, they will always attract, and if you have guessed the second one is the answer, that is absolutely correct. Let us go to the fourth question. The poles of a magnet are named dash and dash. North and east, north and west, north and south. Children, a magnet always has two poles. But which is the correct answer? Try to guess it. And if you have guessed it as north and south, your answer is correct. Yes, a magnet has two poles, north and south. Let us go to the fifth question. What is the space or area around a magnet where the force is? That means this space, whether it is magnetism, magnetic pole or magnetic field. Magnetism is the force of attraction or repulsion. Magnetic pole are the two poles of a magnet, north pole and south pole. And the correct answer to this question is magnetic field, which is the area around the magnet. And let us come to the sixth and the last question. When a magnet is freely suspended, it points towards dash direction. Southwest, south north, north south. In the activity we had performed outside, we suspended a magnet with the help of a thread. And the magnet pointed towards north-south direction. And the answer to this question will be the third one, that is the north-south direction. Students, if you could answer all these questions correctly, your knowledge about this chapter is very, very good. Students, let us play a very, very easy quiz about magnets. Look at this pair of magnets and take those pairs that will attract or repel. The first one, North Pole, South Pole. The correct answer, attract. The second one, South Pole, South Pole. And the correct answer will be, if you have guessed it as repel, that is very, very correct answer. The third one, North Pole, North Pole, like poles. And the answer is repel. The fourth one, South Pole, North Pole, opposite poles, attract. After this, students, I would like to give you a very simple project or activity. You come to your class with your set of geometry box. Now, can you sort out the magnetic as well as the non-magnetic materials and place them in two different columns? I'm sure this will be a very interesting activity for you to perform. Students, I'm sure that while on our journey to the world of magnets, you have learned, you have gained knowledge and understanding and have enjoyed during the lesson, and your knowledge about the world of magnets has improved a lot.